We are looking at how to encrypt an external or removable device so that if you've put your personal files on it as a backup, you don't have to worry if someone steals it or something. Obviously, you want to have redundancy, but I'm talking about the privacy aspect here, and that's it. We're talking about them plugging it into their computer and being able to access your private files. We want to do away with that by using encryption. We're going to be doing it entirely through the Linux terminal. So for tonight's demonstration, I've got simply this.
Okay.
It's a Kingston Data Traveler 16 gigabyte USB flash drive.
Right.
Hey, I mean, it works. You want to throw some files on it and keep a backup of those needed files? First of all, what's a backup? A backup is redundant copies of your stuff.
Right.
I've got a bunch of nice pictures of my kids on my computer. They are not backed up if I move them to this.
Right.
Because this is now the only copy.
Correct.
But they are backed up if you move them to two of those. Right?
Yeah, but preferably, let's copy them. Let's
Right.
make redundant copies
Right.
so that if this one gets destroyed or lost or stolen or whatever, and they fail, you know, USB flash drives, they fail after so much use. So making sure that you have redundancy and copies and something off-site so that if there's a fire or something like that, they're gone. Don't leave these things plugged into your system, because then if you get hit by a power surge and your computer gets shot, guess what? So does the thing plugged into the USB port. So
Right.
those are just kind of tips that don't have anything to do with encryption. But tonight we're going to learn how to encrypt this. So I'm going to plug this in to my computer here, and let's see what happens. Here we go. So I'm just plugging this into my laptop. And no applications to open it, but there it is on my desktop. I'm going to just double click on it, and you'll see that I have a top secret file in there. And within that top secret file, I've got something secret. It could be anything, right? So now the process that we're going to use tonight is entirely destructive. So we're going to be starting with a drive that has nothing on it, essentially.
Okay.
Keeping in mind that if you've already got data on that drive, you need to move it off to more redundant storage so that we can now encrypt this. So the advantages to encrypting this file system essentially are you have to know the password in order to access it.
Right.
So the advantage then, of course, being if somebody gets a hold of that data drive, they're not going to be able to open the files, but you will be. And we're not individually encrypting files and having to decrypt them. No. We're setting it up so that you just simply enter a password in order to mount it. And then you can access it just like any other USB drive. We ready to get into it?
Sure are.
All right, let's bring up our Linux terminal here. I'm using Ubuntu Mate. This will work on any flavor of Linux. And we're going to follow, steps that are generic to any Debian derivative operating system. So that's Ubuntu, Debian, of course, any Ubuntu like Ubuntu Mate or Ubuntu Kubuntu or anything else. Anything that is based on, Debian and has apt-get. That said, the steps will work just fine if you want to use yum as well, but you're going to have to substitute some commands, all right? Okay, so with that drive plugged in, watch what happens when I go ls/dev sd star. You see how I've got SDA and SDB? Okay, so that's two hard drives currently connected to my computer. If I unplug that drive from my computer, okay, because it's not mounted, so I can do that now, and then do that same command, you'll notice I do not have SDB anymore.
Right.
So, safe to say, I mean, really cheap and dirty trick to find out what the drive assignment is, but hey, that's SDB right there. So when I plug that in, if I can find the USB port, there we go. Help me out here. Okay, I'm going to just cancel out the GUI stuff, do an ls again, and you'll see SDB is in existence. Now, key point here, we are encrypting a partition on this drive.
So not the whole drive.
Not the drive as in a device. If you do encrypt the device, so that's /dev/SDB, you're not going to be able to access it. You're not going to be able to mount it, and the headers are going to be messed up. You can fix that by deleting everything and setting it back to unformatted in gparted or something like that, or fdisk, but we're going to save you the trouble by just telling you right off the bat, we've got to have a partition. This particular disk already has an SDB1, so we know that that is in fact, the partition. But if you don't have a partition table on your disk, you can create one with your favorite partition editor, such as gparted. So the first thing I need to do is become root in Ubuntu. I'm going to type sudo su and enter my password. In Debian, I would just type su and hit enter, and that is spelled SU for those of you who are just listening. So now that I am root, I'm going to type apt-get update. That just simply downloads all the latest packages from the repositories so that anything I install is going to be the latest and greatest. Then I'm going to go apt-get install, and we need that particular package that's going to allow us to do this. We're going to type crypt setup and then hit enter. My particular system already has crypt setup installed. You'll see this crypt setup already has the newest version in Ubuntu. So you can run that command, just make sure that you've got the latest version, and you'll be good to go. So a couple of steps here. First of all, we need to actually make the drive, the partition I should say, encrypted. We're going to use what's called LUKS, L-U-K-S, and it's all done through crypt setup, and nice and simple if you follow these steps. So we know that we have dev/sdb1, so that's what we want to, in fact, encrypt. So the command in order to do this, knowing that, is crypt setup --. I'm going to do verbose first of all so that I can see the output here. Then I'm going to go -- verify passphrase. What that does is it tells the system to ask me for the password twice, just in case I typo, because you don't want to mess that up. And then we're going to use 512-bit LUKS format, and it's capital F. And then the device itself. Be very, very careful here. Dev SDB1. And I say be careful because this is entirely destructive. It's going to wipe anything that's on that disk and encrypt it on that partition, I should say. So if you accidentally put SDA1 and that's your main hard drive, you're going to destroy your entire world. All right? And that's where backups come in. So we're going to hit enter on that. And it says, it warns me, just like Robbie does, hey, are you sure you want to do this? And I need to type uppercase yes. Make sure you read that. It's irrevocable. Yes.
I love how it says uppercase yes, but it's all lowercase.
Well, it does that so that you actually have to think about it. Okay, enter your passphrase. I'm just going to enter a password here to use. And then there's that verify passphrase that asks for a second time. And now cannot format. Okay, it is still in use. Let's make sure that it is not in use. Let's see what is causing that. It is mounted to Ubuntu, so I can eject that. Now, I could also, if it's mounted, because I really want to teach you this in the terminal, let's do mount. And we can see, now we can go mount and then pipe grep, and we're going to go SDB1. This is a better way to do it. And you see SDB1 is mounted on /media/Robbie/USB 16 gigabyte. So let's see if I can just unmount that forcibly from here. I'm going to copy that to my clipboard, if I may. You may not be able to do that if you're in a true terminal. So I'm going to go umount and then paste that in. And it's gone. Okay, so now I should be able to run that command, because if I run that grep again, notice it is no longer mounted to my file system. Okay, so nice to have these little issues come up so that I can show you what to do if you encounter it. Okay, so then I've just cursored up to recreate that command, and then I'm going to type yes, enter my passphrase again. I've got to kind of start over here. And here we go. It's not going to take us much time. Done. Okay, so now that drive is an encrypted partition. It has nothing on it. It has no file system. It's not ready to go whatsoever. We can't even mount it. What we need to do is we need to, in fact, mount it using the cryptography system. So first of all, I want to confirm that it worked. I know that it did, but let's just do crypt setup, and then we're going to do what's called a LUKS dump. And again, it includes a capital D and then dev SDB1. Now, if things went well, you're going to see key slot 0 is enabled. That means that my password is stored in the headers of that drive. Now, if I do a LUKS dump on SDA1, you'll notice that dev SDA1 is not a valid LUKS device. It's not encrypted. So I can see that SDB1 is encrypted. It has AES, SHA-256, and it's all set. 512 bits. It's good to go. So now Next step is to, in fact, open that device, and we need to do that through, of course, the decryption system. So I'm going to just jump into, you know what, I'm going to create, what's the word? A mapper. Looking for the words in this noggin of mine. We're going to create a mapper to this drive. So now that it's encrypted, we can no longer just mount SDB1.
Right.
Because it's encrypted. We have to create a mapper so that we can then mount that decrypted mapper. Okay?
Mm-hmm. I follow.
Yeah? So let's try it in kind of a test case. We're not going to set up a crypt tab or anything just yet. So we're going to go crypt setup Luke's open with a capital O, surprise, and then dev/SDB1, and we're going to call this, what do you want to call it, backup?
Yes.
Enter the passphrase for dev/SDB1 because there is one. If you enter it correctly, it has created the mapper. So now if I go ls dev mapper, I should now see one called backup. Do you see that? Mm-hmm. So I can now start using that. So watch this. Thinking of that mapper as now my decrypted version of the partition, I can format it. Mm-hmm. Okay? So now it's time to actually make this thing into something that's usable. What is going on?
I'm sorry.
Trying to do a show here.
It's the chat room.
What's going on in the chat room?
Dying for like the last 90 seconds.
Go ahead, Jeff. Go ahead, share.
What are you guys doing to him?
I'm reading the chat room, so I know
I'm trying
exactly
to
what
do
he's
a
on.
presentation here, chat room.
It's
Live TV.
I'm sorry.
Jeff is now 9 years old.
It's because I've got a son named Luke.
Lyndon says, let's make a map to find Luke's dump.
You're going on and on about Luke's stuff, but I'm picturing like
His son's name is Luke. It didn't click until the chat room brought it up.
I'm dying over here as you're going on about Luke's dump, and I'm trying not to laugh. Oh my goodness, I'm crying.
How many Lukes are watching this right now? Please comment below as they're watching it on your phone.
On the loop.
On the loop.
Oh my goodness! I
Make a map.
normally can control myself.
Not this time.
This time, and you kept cutting back to the mic, and I'm like, trying not to die, and I couldn't do it. Oh, Lyndon, you're horrible.
Love it.
I'm
Wow.
so happy that we're past that point. I am going to have to do another Luke stump near the end of this. Just to show you.
You're
that
regularly doing it.
You guys are killing me. Oh my gosh.
this is the real show. This isn't even the bloopers reel. Wow.
Woo. Oh my goodness. I am crying. There's people in the chat room crying too.
We apologize to those of you who are just here to learn. I mean you, Luke. All right, are we ready?
Oh,
Let's do
definitely
this.
not.
Yes.
Ready to make a file system? Do we understand where we're at?
Yes.
We've created a mapper, which is basically what would have normally been our /dev/SDB1 if
Right.
it were not encrypted.
Right.
We've created that mapper so that we can now format it. Okay, so we're going to go make fs, just like you normally would, .ext3, okay, because that's what I'm going to create this as, /dev/mapper/backup. Okay, so now it's going to tell me, all right, it's just doing it. Doing it. That's going to take a little bit more time.
You know, one of the things that it's always kind of irked me a little bit about the terminal system is you never get that percentage. There's like, it just sits there and it's thinking, and you're like,
you look at a
how
Windows
long?
percentage bar and it's going to tell you,
oh, I know. It says like,
10
there's
minutes.
10% left.
200 hours.
Yes.
4 minutes.
I know, but just something to reference. Like I did an update on my system the other
Yeah.
day, and it's just, I'm waiting and waiting. It gets to the point where you're going, did my system freeze?
Yeah.
You know?
So if you think it might have froze,
Oh, there's a thing you can do. Robbie showed this.
There's a thing. That's
There
so
is a
technical.
thing that you
There's a
can do.
thing.
Sasha's going to explain it.
There's a thing you can do. What you do is you call Robbie.
No. Bring up another terminal window, Jeff. And type IO top to see what's using your IO, your inputs and outputs. Notice I'm not super user, so sudo IO top instead. And that's going to show me what's currently using my
Look at
file
that.
system.
Cool, eh?
So you see the top one is make, and it's going to come and go, but makefs.ext3.
Right.
And it's doing that, and it's using my I/O. You see that popping up every now and again? So that tells me
It's still
that
working.
makefs.ext3 is doing stuff with the I/O enough so that it's hitting top.
Right.
Love it.
Okay?
Took
So
the
that-
words right out of my mouth.
Well, that answers your, that problem of, is it actually doing anything?
yes.
Now you know.
Perfect.
Now you know. And we're having a great time tonight learning about how to encrypt this USB flash drive. Now it's all done, and you'll see that that's simply returned to the prompt. So now, Jeff, if I type sudo, I don't need sudo because I am root right now. But if I do iotop, note that makefs.ext3 is no longer going to show up there because it's
Right.
finished, right? It's not doing anything anymore. And so the I/O is finished being used by that application. So now we have that drive encrypted and formatted as ext3. Let's bring it up in our GUI because that may be why how we're going to access that moving forward. Let's take it from scratch. Okay. No software needed. I just ejected it and going to plug it back in. Let's see what happens. Sometimes your session will memorize the password. So, all right, click on it. That's what we're looking for. Enter a passphrase to do what? Unlock the volume. So you notice I can't even access it unless I know the password. I'm going to enter some gibberish. And we're going to say forget password immediately and connect. And you'll notice
Nothing's there. Oh,
went nowhere, and then it says error unlocking dev/sdb1, no key available with this passphrase. Incidentally, that's the same error message that you're going to receive if you've accidentally created the volume on the device, so SDB versus SDB1.
Right.
So keep that in mind. If you're seeing that error message and you know you've got the password right, maybe you did it on the block device rather than the partition. So let's try it with the real password. I'm going to click on it again, and I'm going to type in my password here, and I'm going to go forget password immediately because I don't want my computer to remember it. Connect. Did I type it right? There we go.
Sweet.
Mistyped it the first time. So now I've got a completely empty ext3 file system. So you'll see that that is now accessible on this computer. So on next week's episode, we're going to learn a couple more things. We're going to learn now, because it is a read-only file system, I don't have access to it as this user. It's not read-only, pardon me. It's owned by root. So only root can now write to that file system. We may want to make it so that our user can actually access that drive. We're going to look at that next week, and we're going to look at how to make it so that my computer and my computer alone can open that drive without a password anytime I pop that in.
okay.
And I'm talking not just from the GUI. So of course I could say remember forever. Sure, that's the GUI. I want to think about things like a server where I only have SSH access, for example, or I only have a terminal. I don't have a GUI, so how do we do that? We're going to learn about creating a Encrypt tab. We're going to learn how to actually mount that device through our FS tab and decrypt it automatically using a key file. So that's going to all happen next week on episode 506. So if you've enjoyed learning about how to create this volume, we're going to learn how to take it one step further and make it into the perfect backup set so that we can start throwing our files on it, and then when we eject it, it's no longer going to be accessible on other computers.
Cool. Now, in the chat room, the FU says that Luke supports 8 passphrase slots.
That's correct, yes.
So you can have multiple passphrases.
I know what you're doing. I
What?
know what you're doing.
I'm just relaying what's in the room. What am I doing?
I know what the foo is doing.
Uh-oh. What did I do? Did I open a can of worms?
No, Jeff. Crypt setup. Luke's dump. Dev SDB1. And now I can show you that we have 8 key slots. You are correct. The foo.
I love
Played.
this show.
Well played.
I love this show. There we are.
I am so done. I'm just like done.
I pretty well kept
Have you
it.
missed this,
the whole
Jeff?
thing, but
Yeah.
the funniest encryption tutorial on YouTube to date.